Hello and welcome to eMind's Technology. My name is Jay Chandran. In this video, we are going to learn about BGP, Border Gateway Routing Protocol. Border Gateway Routing Protocol, BGP, Border Gateway Protocol. And this is an excellent protocol which you have not seen like this before. You might have seen like OSPF link state protocol, and then RIP, a distance vector protocol, and EIGRP, an advanced distance vector protocol. This BGP is a special protocol which is designed to support huge network, internet. Now, if you take EIGRP or OSPF or RIP, they are IGP protocols, interior gateway protocols. They work very good within an autonomous system. They find the best route according to their metric. If it is RIP, it finds a route with a lower hop count. If it is EIGRP, it finds the metric with a more bandwidth and less delay. If it is OSPF, it finds the best route to various destinations based on the cost. Whereas BGP is a protocol which finds the shortest path by seeing the number of hop counts. Means here one hop means one autonomous system. How many hops in the middle, how many autonomous system in the middle. Smaller the autonomous system, smaller the number of autonomous system in the path, better is the path. That's how BGP by default selects a route to various destination. So BGP is called as a path vector protocol. For various destination, it shows different routes that is possible, the routes that can be taken to reach various destinations that is there in different autonomous system. So BGP is a protocol that is designed, by design itself, it is designed to support a huge network like internet. It's an internet protocol. BGP supports something called multi-homing. What is multi-homing? When our enterprises, when our autonomous system is connected to more than one ISP, two or more ISPs, then we call it as a multi-homing. Now what you see here is multi-homing. Router C, A and B is our enterprises, our autonomous system. You may be running EIGRP in it or OSPF in it. Now you talk to your customers through two ISPs, ISP A and ISP B, to two different ISPs. Now these two different ISP connected to our enterprises, this particular setup we call it as multi-homing. Now why do one connect to two ISP? Why should our enterprises need to connect to two ISPs? One for for reliability. If connection between one ISP goes down, I have another ISP to back up. Another one is to improve the performance, meaning some customers may be having shortest path via ISP A, easy reachable. Some customer may be having shortest path via ISP B. So I can take fine decision, find route and reach my customers. So to increase the reliability and performance in path selection, we need multi-homing. Now when we have this type of multi-homing setup, there are different ways in which the routes are learned. One is learning only default route from all the providers. You learn only default route from ISP A and ISP B. Another one is default route from all providers and also a partial table, meaning if you will have a regular customer or a regular branch office which you want to interact, for those branch office, for those regular customer, you will have a proper route, precise route. For the rest, you will have a default route. Or to an ISP, you will have a proper route. For the rest, you will have a default route. So that's what partial table. Next one is, the third type is full route, learning the entire routing table of ISP into our router in our autonomous system. For that, our router should be really, having big memory, big processor. It should be a high-end router. Usually ISP will learn from another ISP the entire routing table. Right. So these are all the three different ways via which the routes are learned inside an autonomous system. Now, BGP is a path vector protocol. BGP works between autonomous system, whereas RIP, if you see in this diagram, RIP version 2, ISIS, OSPF and EIGRP, they all work within an autonomous system, inside an autonomous system. BGP is a protocol which is meant to work between autonomous system. It is not that I cannot run RIP between autonomous system. I can run RIP. It's only one hop, right? I can really run RIP, but the attributes, meaning if I will have some policies in my office, I cannot implement my policies on the path selection. So if you want to implement all your rules and policies of your company, you need a protocol which will have a lot of flexible attributes, rich metrics. That's why we go for BGP. Now, what is an autonomous system? First of all, an autonomous system is a collection of network under a single technical administration. Means 65250 autonomous system. All the routers inside here, they run a common IGP protocol. They all have a common policy and rules. It belongs to a single enterprises. So it's a single technical administration. That's why we call it as an autonomous system. Now BGP works between these autonomous systems. Now what is IGP? IGP means the protocol that operates within an autonomous system. Example, RIP, OSPF, EIGRP. Once there was also a protocol called ISIS, intermediate system to intermediate system, which is no more. Right. BGP is used between autonomous system, and also BGP ensures loop-free routing information. It guarantees 100% loop-free routing information by selecting the path with the lower autonomous system jumps. We will be seeing that in detail in coming classes and coming videos. As I told you, BGP is a path vector protocol. Why it is called as path vector protocol? Look at here. I am seeing an output here under autonomous system 64512. I have path advertised 64520, 64600, 64700. What is this? These are all the path, these are all the autonomous system via which this advertisement has come. 192.160.24.0 has come from this autonomous system 64700 via 64600, 6450, 520. At last it has reached 64512. It shows the path via which the routes has been learned. That's why it is a path vector protocol. If you take an IGP protocol, they don't announce a path, they announce the networks and the metric to reach those networks. But BGP announces the path to various networks. BGP describes path by using what? By using attributes. We will be learning attributes in our final video. Now attribute is nothing but rich metric. Rich metric, not simple metric, rich metric. We'll talk about that in coming slides. Now with the help of rich metrics that we have in BGP, we administrator can define our policies and rules to say how my data should flow when it passes various autonomous system. The path selection will be based on the attributes that we set on our BGP routers. That's why it is called as a path vector protocol. Now BGP is also a hop by hop routing protocol, like RIP. RIP is a hop by hop routing protocol, where in RIP one hop is equal to one router, one jump to a router. Here one hop means one autonomous system. One autonomous system to another autonomous system. BGP will by default, if you are not setting any metric, if you are not changing any attribute, by default BGP will select a path with the less number of hops, meaning with the less number of autonomous system on the path. Now BGP characteristics, meaning who can go for BGP and who should not go for BGP. Now BGP is most appropriate when at least one of the following is there, meaning I'm just reading the statement here. First one, let me make you understand what is this. An autonomous system allows packet to transit through it to reach the other autonomous system, meaning I have an autonomous system here. I have autonomous system 64520. Now if someone wants to go from 65250 to 65000, saying again, if someone wants to go from D to B, they cannot go simply directly to that B router from D. They should pass via A router. A is another autonomous system which is not yours. A is neither your destination nor your source, but A is used to reach your destination. Then this autonomous system where A is called as a transit autonomous system, transiting, passing through. Now if you will allow someone's packet to transit through your autonomous system, definitely you will have some policies. You will not simply allow everyone. Say for example, we are using internet connection, meaning we are using their autonomous system. For that we are paying. So there is a policy. If I pay this much of bandwidth is given to me, and from this time to this time I am allowed. So that's what transit means, pass through. And BGP is good if you have multi-homing, and BGP is good if you have a lot of policies and rules to be given to the traffic flow. You have some policies and rules for the path selection for your traffic to go, then you need BGP. Now where BGP is not appropriate,